Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So our problem here is 243 to the power of x, or 243 to the power of what, equals 4. So our goal here is to find the value of x. Well, there's actually two ways of doing this. So depending on what you think, you could either use the first method or the second method. So let me do the first method first. So first, let me write this right here, 243 to the power of x equals 4. So our goal here is to make these two bases the same. We want to make these two bases the same. So to make 243 and 4 the same, well, we can change 243 to 4 to the power of 4. So we just changed our base from 243 to 4. And now that our base is the same as this one, well, this is actually 4 to the power of 4 to the power of x, and this is equal to 4. And now 4 to the power of 4 to the power of x, well, this is the same thing as 4 to the power of 4 times x. And this is equal to 4. Now, 4 to the power of 4x equals 4, right? Well, this is the same thing, 4 is the same thing as 4 to the power of 1. And because these two bases are the same, then that also means that our exponents here, these two are the same as well. So why don't we ignore these bases for now, and let's just focus on our exponents. We could write our equation 4x, or 4 times x, equals 1. We're setting our exponents here the same because if our bases are the same, then our exponents are as well. So now all we have to do is simply solve for x. So I'm going to divide by 4 on both sides to isolate x, and we are left with x equals 1/4. And that's our answer to this problem. Now, why don't we check our work here? Let's go back to our problem here, and let's plug in 1/4 for x. So we have 243 to the power of 1/4. 243 to the power of 1/4, this equals 4. And something to the power of 1/4 isn't the same thing as 243 to the 4th root. This is the same thing as 243 to the 4th root. And this equals 4. So what to the power of 4 equals 243? This is essentially what 243 to the 4th root is asking. And 4 to the power of 4 actually equals 243. So 243 to the 4th root is simply 4. And 4 does indeed equal 4. So this is right, meaning our answer is 1/4. So now let me show you guys the second method of doing this. All right, so our second method is, well, we're going to ignore the x here, and we're just going to find out, let's just focus on this 243. 243 to the x root equals 4. We're going to first find that out. So 243 to the what root equals 4? Well, as we already know, that's 4, right? 243 to the 4th root equals 4. So we have, this isn't actually the actual, I'm just going to say that this is y. So y equals 4. So 243 to the 4th root 243 to the fourth root is equal to 4. And isn't this the same thing as saying 243 to the power of 1/4 equals 4? Because remember, when we have anything to the root of anything, let's say we have a to the root of b. Well, this is the same thing as a to the power of 1 over b. So 243 to the fourth root is the same thing as 243 to the power of 1/4. And x here is 1/4 as well. So this is our second method. And that's how you solve this exponential problem. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 10 to the power of 3 minus x equals 1. So whenever we're solving exponential equations similar to this one, we always want to make sure that our bases here, in this case 10 and 1, we want to make them the same. Because let's just say I have a to the power of x, and this is equal to a to the power of y. Well, we know that these two terms are equal to each other or the same, and we can see that both of them have a base of a. Well, in this case, doesn't that mean that their exponents are the same as well? Because if they're different, then that means this would be wrong. They can't be different because their base is already the same, meaning their exponents have to be the same as well. So in this case, if we were to change the bases so that they're the same, then we would know that the exponents are the same as well, so we could just set the exponents equal to each other and solve for x. So we want to make the bases of 10 and 1 equal each other. Well, that means that we have to change one of the bases. And we can't really change 10 to be equal to 1, so why don't we change 1? Well, 10 to the power of what equals 1? 0, right? Because anything to the power of 0 actually equals 1. So we should change 1 to 10 to the power of 0. And this still equals 10 to the power of 3 minus x. Now notice how these two bases are the same, just like this one. And think of 3 minus x as x and the 0 as y. Because these two bases are the same, then that means that these two exponents are the same as well. So we can just ignore the bases for now and just set 3 minus x equal to 0. And now, as you can see, we've created a simple equation using our method. So now, to get the value of x, we're going to have to make it go to the right side. So we're going to add x on both sides. And these two cancel out. So we're left with 3 equals 0 plus x is x. So now we have our value for x. Now, why don't we go ahead and plug it in to our equation? So this gives us 10 to the power of 3 minus 3 equals x. So 3 equals 1. 10 to the power of 3 minus 3 is 0 equals 1. And remember, anything to the power of 0 equals 1. So 10 to the power of 0 equals 1. So we have 1 equals 1. And this is right, meaning our answer of x equals 3 is right.